So my name is Andy Pernsteiner. I'm field CTO for Vast. I've been here since before we had something that we could sell. And so I've been along the way for creating the product that we have today, which I won't give you all the details. We can go and have those as sidebars afterwards. But basically, Vast has created a scale-out platform for storing, processing, analyzing, and deriving insight from data. And we work with some of the most data-intensive organizations in the world, scaling into hundreds of petabytes or exabytes worth of capacity, scaling to terabytes a second worth of bandwidth, doing things across all types of industries. So many of the people who are training large-scale foundational models are using Vast as the underpinning and the place that the data lives and the place that the data is processed. But there's a lot of other applications and use cases that people are using us for. So I wanted to introduce a couple of people who I have the pleasure of meeting. Actually, some of them, I met them this morning. We've met on Zooms and calls before, but now that we're here in person. The first of which is Dave Lahansky, the Global VP of Business Development, or SVP, sorry.
EVP.
I missed, oh, it's EVP.
Even one higher, yeah. How about that? It keeps,
there.
every minute it keeps going up.
Yeah. Dave's been over at the NHL for how long now?
19 years, yeah. Although, like we joked around before, we count in seasons, but it's about to be 20 seasons. Yeah.
Outstanding. How many of you here are hockey fans?
Oh,
All right.
come on. Oh, you're being nice.
Free tickets for everybody. I'm also joined by Adam Ryerson. He's the product manager who's in charge of, well, actually, you could explain it.
Yeah, so I'm the product manager for the AI blueprint for video search and summarization. Pretty much I lead a lot of the AI agents in the video realm. So anything that has to do with vision or images, both live stream and VOD. I handle that as far as taking that and being able to utilize it inside of an agentic workspace. So being able to connect it to any type of bots or connecting it to existing applications and want to leverage video and AI. I lead those efforts at NVIDIA.
Outstanding. How many of you in here have seen the demo that we put together in conjunction with the NHL and NVIDIA? Okay. Well, spoiler alert, I'm going to probably play it again. But I'll wait till the end. So the first thing I wanted to do is kind of talk with Dave here about the partnership that Vast and the NHL have had. It's been actually more than 6 years now that we've worked together. Not nearly the 19 that you've been working there, but in Vast years, that's forever. You're one of the first early adopter customers. We did a lot of co-development with your team to get everything up and running. And in the very beginning, Vast was acting as the data store for all of the edit workstations, right? So if people who are editing footage to put into broadcasts or put into highlight reels, they would edit on the Vast data platform. And over the years, we evolved that relationship, right? And so we'll talk a little bit about it, but basically, Vast now has a platform in every single NHL arena. How many arenas are there now? 32. 32 arenas. And those arenas are feeding the footage for every game back to their data center in the least expensive place in the world. Where is your data center?
Of course, yeah, New York City.
Yeah, in New York City. In Manhattan, in Hudson Yards, probably one of the nicest offices you could get. It's a great office. If you ever go there, you get a view of Madison Square Garden, which doesn't look quite as nice as the building that you're in, but it's a great arena. And so all of the footage for every game that's being generated at the arenas is coming back and it's being edited on in the NHL's headquarters. In addition to that, the entirety of the NHL archive, all of the data, all of the footage going back as far back as there were broadcasts to record, is being migrated over to the Vast data platform. And maybe you could help us understand, like, how far back does that footage go?
Yeah, it goes back a little more than 100 years. So 1917 is really kind of when we first have like an asset on file. But we've got, and you know these numbers probably better than me, we've got a little more than 550,000 hours of video footage. I think we have a little more than 25 million images, and that's everything from snapshots of players to copied score sheets from the 1920s and 30s. And there's, you know, a lot of game video, of course, for the NHL. There's game video from other leagues that we've accumulated over time, NCAA, junior hockey, international competitions. And then there's, you know, the things that we've created along the way, documentaries, shoulder programming, behind the scenes footage, and it's all in there.
Yeah, it's pretty amazing. Basically, there's just a big tape library sitting in this low-cost data center, and was it like on the 20-something floor building in New York City?
23rd floor.
But we're moving it all over to a vast platform so that there's more options for people when they're trying to go and find footage. Maybe you could talk a little bit about some of the things that you would like to do as you move all that stuff onto a vast platform.
Yeah, you know, I mean, it's fair to say it's underutilized, right? We have this incredible repository of historical information, and we haven't really used it. And part of that reason is because we haven't really been able to use it when we really think about the modern day applications. And we were talking a little bit before, there's so many, but you know, hockey is unique in that it was really fast, right? And that's great as a sport for young people who are obviously thinking about their time and how they consume it. And other sports have done things to try and shrink the amount of time that they play to be faster. So that's great for us. But it also creates a bit of an issue because we've got 60 minutes of actual play, and the stoppages in a hockey game are really short, anywhere from 10 to 15 seconds. So being able to tell stories in the context of a game is really hard for us, explaining why one player is better than another player, why one team's so good at a certain aspect of a match. Conversely, if you think about an NFL game, there's 17 minutes of actual play and 2.5 hours and they're brilliant, right? It's storytelling. It's highlights and replays and stats and analytics and bar charts and graphs, and they're telling the story along the way to pull you in. So as a potential use case, you know, we've got play-by-play people. They're calling the game, they're calling the game, they're calling the game. There's a whistle. They've got 10 seconds to call down to their producer in a truck down somewhere in the bowels of the arena and say, hey, can you take a look at this for me? Something happened in the game, and I want to know when the last time an American-born left-wing rookie did this. By the time they get it back, forget it. We're in the third period and the story's over. So how do we build a solution that could allow us to pull data and video quickly, and ideally not even have to be dependent on that sort of verbal request? Can it be automated in a tray that's just sitting there on an iPad, and as the commentator's calling the game, it pulls up the last time that event happened by an American player, whatever it was, whatever. So in every possible way, but in the most important way, maybe the way we deliver our live game, we haven't been able to leverage that archive to help us tell stories and or, you know, communicate the importance of the history of the league.
Wow, no, that sounds like an ambitious task. So I think what I'll do now is
Now shift it to him.
Yeah, well, we'll talk. We're going to talk a little bit. So, you know, I have to say, like the work that we've been doing with you guys over the last several months has kind of been mind-blowing. But I want to talk a little bit about the history of VAST and NVIDIA, because it's not just about what we're doing today. It's about how we got here, right? So, you know, VAST focused on the most data-intensive organizations initially, typically in the world of high-performance computing, where you know, the speed matters, the scale matters, the uptime matters. Of course, nowadays, the cost of an HPC cluster, if you're embedding it with GPUs, is so much higher. So it's even more important to keep things up and running and moving fast. But initially, our first foray with NVIDIA was partnering on a project known as GPU Direct, or is it called Project Magnum, John? I forgot. Magnum IO. Which basically allowed for a faster path from a data store into GPU memory, shortening the time that it took to get to first byte and start processing, and also reducing the extra work that the GPU would have to do in order to move that data. So it was a net win on many fronts. That was the first area that we focused on, and then we went through all the validations that NVIDIA created around SuperPod and BasePod, and basically the ability to know that when you deploy an NVIDIA SuperPod or a derivative, that if you deploy VAST alongside it, you have a certified solution that's been tested and validated not only by us, but also by your teams. And so, you know, over the years, we've been very tight with NVIDIA and working on this. And, you know, more recently, we started realizing that, you know, training has been a big focus for a lot of the large scale, you know, sort of hyperscalers over the last several years. But at some point, they have to make money. At some point, applications have to be derived. It's not enough to just train a model forever. You need to get some value out of it. And so a little bit earlier last year, I think in October, we announced something we call the Insight Engine, which is a partnership between VAST and NVIDIA to allow NVIDIA applications to run directly on the VAST data platform to keep it much simpler and more sort of integrated for customers who are trying to deploy AI applications at scale on their own data. And so, you know, Adam works on a team that works on some of the leading edge models as well as pipelines. So maybe, Adam, you could talk a little bit about the kinds of things that you're putting together.
Yeah, so two things come to mind when I think about this use case that resonates. It's one, the massive amounts of data that's coming in, 500,000 hours of video that you want to be able to ingest and be able to access at any time. Like you said, they want to be able to access it on the fly when a game is taking place. They want to be able to, maybe access it for a specific viewer who might want to create a customized reel. So that's one part of it. The other part of it is being able to pull insights that you can't get from any other type of modality. If you have metadata that might be, giving stats on a player, what we can pull from video is still unknown. We continue to find more things each year, and this is going to be able to start unlocking that. So one of the big things that we've been developing at NVIDIA are our NIMs, or our NVIDIA Inference Microservices. Now, these are various AI models that we've optimized. So we've then taken those NIMs and combined them in a blueprint that allows us to deploy solutions easier. So instead of having to build a video search and summarization application or pipeline from scratch, we take the components, we put them together, and we use that as a reference architecture that can then be taken by VAST. They can utilize the parts they want, such as the vision language models or the retriever and the embedding, and then they can apply it and build it into their pipeline. So we make it easy for the most important parts to be brought in and utilized. On top of that, we make it so that it can be easily fine-tuned. So these models that are being utilized can be fine-tuned for the NHL data, so that as they use that existing corpus of 500,000 hours to create a VLM that is specialized in that hockey arena. And therefore, when more hockey footage continues to come in, it's getting better and better each time at identifying when are the highlights happening, when are the things that the fans are going crazy for or looking for. So this is what we're trying to empower and make it so that it can be ran on the VAST platform and pretty much accelerate at this rate.
That's awesome. Who in here knows what a VLM is?
Ah, probably explain what that is.
Yeah, let's talk.
Yeah. Sorry, I go from so many technical things.
It happens.
Yeah, so VLMs, or vision language models, are foundational models that allow you to ingest video or images and describe them in natural language. A lot of times with traditional computer vision, there'd be bounding boxes and segmentation masks for identifying what is a car and how is a car moving. But with foundational models, so these traditional models also require a lot of data and training to begin with. So you'd have to train it on, all right, what is a car? How is that car moving? But if you take that same model and you show it a table, it won't know what that table is. The idea behind foundational models or vision language models is that you can point it at most general things, and it'll have a very good understanding of what the things are on the scene, what actions are taking place, because it's been trained on a very generalized corpus of data. So it gives a very quick starting point. You don't have to start from scratch. You don't need to train for hundreds of thousands of hours before you have something. You can start using this vision language model out of the box to get a very good description of what's taking place in the scene, understanding how a game is playing, and then be able to identify players, things such as that.
I'd just say, from a sports standpoint, you can imagine how excited we are about this, because the entire history of our product has been captured visually.
Yeah.
So when you talk about, or even from a predictive standpoint, you want to be able to pattern or see what happened next. We have 100 years of being able to see what happened next, game by game, year by year, decade by decade. And it's all in one closed environment. So the ability to apply this now, it's
untapping. It's pretty much letting you tap into a lot of video footage that might be sitting around. And say, hey, get this highlight from the last 20 years, finding these specific highlights. Yeah.
Now, you mentioned earlier that you're working on some sort of reference architectures. Can you describe what the VSS blueprint is?
So the VSS blueprint it consists of two major pipelines. One of them is an ingestion pipeline, and the second is a retrieval pipeline. So on the ingestion side, this is where we're taking in the 500,000 hours of video, and we're able to process it and parallelize it across many GPUs. Pretty much what we're doing is we're taking these games and we're breaking them up into smaller chunks or smaller clips that are about 10 to 15 seconds each. We parallelize those across many GPUs into these models, and then we're able to process these not in years or months, but in days. We take all this data and we can process it extremely quickly. We see anywhere from 100x to 200x the speed of what it would take a normal person to go through and scan it for themselves. So we ingest this video, we take it and we describe it in natural language, and then we embed it into a database. So once these embeddings are created for these videos, we then scan through those embeddings and we connect the pieces to generate context. So instead of you having these tiny little 10 to 15 second chunks, we stitch those together so that you can actually tell a story about what is happening in the game. What does the play really mean? Or how is the player actually moving throughout that game? And then on the retrieval side, this is where we connect it to a RAG pipeline, or a retrieval augmented generation pipeline, where we can use large language models to either obtain specific key pieces of information. We can do any type of question and answering. We can ask it, we want to search for this specific clip, or we want to know how many times this event has taken place. And this large language model can search through that database, across all the embeddings, and then be able to pull that key information in in near real time.
Yeah. No, I mean, I've been experimenting with this model and the rest of the pipeline for the last several months, and even on day one, when I started interacting with it, I was pretty impressed. Right. At first, I didn't really know how to interact with it, but it's pretty simple. Like, how many of you here use, let's say, ChatGPT? So in ChatGPT, you type in a prompt, you hit the enter key. And it gives you back a response. Well, this is similar, right? Instead of uploading an image and saying, hey, describe what's in this image to me, which is something that some people do, you can upload a video, you can tell it something about it, right? The more information that you give the model when you're uploading the asset, the better the response is going to be. And actually, that's one of the people on my team, Matt, he came up with the idea of having different personas of people who are putting the data in, right? So when you ask a question of something, you want to think about the persona you're trying to sort of focus on. And so, a video editor is one persona. Somebody who's, let's say, going through and looking for sponsorship attribution, right? Maybe you could talk a little bit about some of the iteration that your teams have worked on and trying to figure out the right way to work on these.
Of course, yeah. So a lot of the times when we're building upon this pipeline, we started with a very specific use case. We were in a lot of smart spaces areas, so a lot of like city cameras, traffic cameras, and we started focusing on massive video streams. And from there, as we worked on additional use cases, we started seeing what were their interests, what do they want to be able to do? Do they want to augment this data with other aspects? So we introduced things like audio. On top of that, we saw a lot of interest coming in for video footage that had audio, and they wanted to tie that into their embedding models. On top of that, people also wanted to say, you know what, we actually want to introduce our own CB models. Let's say we have a really good puck tracker that we've been developing for the past 20 years. We want to introduce that puck tracker into this pipeline. Can we do that? And the answer is yes. We make these pipelines extremely customizable because everyone's developing on these NVIDIA GPUs. So we're saying, any way that you want to customize the pipeline to either include dynamic ad placement in order to include statistics directly onto the videos that we're passing in. There are all of these features that we want to include in these pipelines to make it possible to do a lot of these things.
That's awesome. And I guess, Dave, as he starts to kind of talk about some of the capabilities that he has, like, what kinds of things come to mind for you?
Yeah, there are so many. I guess I could say, as a long-term vision, we believe in a big way in personalization and customization, right? That we're going to get to a point where it's going to be very easy for fans to not only customize their own highlight tray, but their own live game experience. You've got a device and you select the camera angle, you select the audio feed, you can talk to your friends, you can turn on betting, you can turn on graphics and visualizations, whatever it might be, right? And we're getting close because some of those individual components are there now. Yep. building that at scale and getting millions of people to be able to use it in real time is another challenge. But the road to that, there's all these steps in play. One in particular, I mean, we're testing and piloting 8K cameras, a variety of 8K and 10K cameras in the building. And when combined with our tracking data, we have an active tracking system right now. There's a sensor in every player jersey. There's a sensor in the puck. Combined with that data, we can create very easily ISOCAM footage where we could each sort of pick a different player to follow around the ice. Then the ability to then crop, edit, apply statistics, and push that out to social media is like unbelievable, right?
Yeah.
And it's never existed before. And so now you're putting this in the hands of our fans, which gives them more relevant content that they care more about because it's their favorite player on their favorite team doing their favorite thing, scoring a goal or making a big hit, and they can sort of create their own
And
experience.
as you mentioned there, he talked about a bunch of things. One of them was like multi-camera tracking. This is something that we developed for warehouses and factories, but we realize it are equally, if not more, applicable in sports arenas. There, all these cameras that are coming in. You want to be able to localize where that player is, spatial ground where that player is, so that you know exactly their coordinates. And so being able to incorporate that and having the agent understand when they're making decisions, how do I use this information? Is this information useful for what the end user is asking for? And then being able to also find specific key chunks of time. I want to know, where do they have breakaway plays? And being able to have that agent say, all right, between these 5 timestamps, there were breakaway plays inside of during that match.
So, and then the ability to go from post game to in game for us is so big to run those workloads on those files like as the game's being happening in real time is unbelievable. At the highest level, I could tell you in more on the business side of things, we've always kind of had this sentiment that the arena is a theater. We're putting on a live show. It needs to be a world-class live show, and thankfully most people who go to see it come away feeling like that was a great show. But now the terminology shifted. It's a studio, right? Because 18,000 people are important, but there's millions and millions and millions and millions out here.
Yeah.
And there was a pretty big drop off between the experience of being live in an NHL arena and then watching it on a television or consuming it on a device. This is going to allow us to sort of change things. And basically, with our partnership, that's what you're enabling. You're allowing us to turn the arena into a studio. We're in process there.
It's been really exciting working with both of your teams, right? I mean, it's really good when we have a use case that a lot of people can identify with. A lot of the times in the world of technology, we focus on the technology and we just sit down in the weeds all the time. But it's been pretty refreshing. I guess, does anyone have any questions that they wanted to ask?
500,000 hours. You said it was about 500,000 hours.
It's somewhere between 500 and 550, but yes.
So how many exabytes is that?
It's actually not exabytes. It's in the 20 petabyte range. Yeah, because remember, if you go back in time in 1917, the resolution was slightly lower. It's obviously, he mentioned 8K cameras a moment ago, and so that's obviously increasing. But even at standard and high def, you can fit a lot in a petabyte. Now, there's new derivatives because now you're going to be generating more things, and it's gonna get much larger, right? And so we'll see that get bigger over time.
What's your annual budget then for storage? About
It's significant.
not many petabytes. How many
Oh,
petabytes?
we're about one now. Aren't we close to a petabyte a season, though?
About a petabyte a season,
less.
I would say. Yeah, I mean, there's approximately 30 teams playing games. What is it, 82 games a year? That's it's a fair amount of footage. Most of the stuff coming out of the arenas right now is standard, not standard. That's a high def, is 1080. There are some cameras that are pushing higher than that, but they aren't necessarily pushing all that footage into the mainstream.
Yeah, to your point, when you get through the whole season, you're close to 1,400 games.
Yeah.
There's a lot of camera content, yeah.
Thank you. David, you talked a little bit about storytelling during the broadcasts. I know that NHL struggles a little bit with promoting superstars and all that just because of how everyone is team oriented. What use cases are you trying to pursue in terms of storytelling outside around social with video clips and kind of narrating stuff like Ovechkin trying to score, the most goals ever and stuff like that? How are you trying to build a brand outside of the broadcast to help with fan adoption and stuff like that?
So it's a great question. More recently, within the last several years, we've realized like geography matters a lot. And the stories we need to tell in the US are very different than the stories we need to tell in Canada, which are very different than the stories we need to tell in Germany. Where hockey's popular in all these places, people know about our best players and the best teams, but we probably need to position it a slightly different way. And Canada, it's on the $5 bill, and right. So it's coming at it a completely different way. But the great opportunity here is we really haven't done a lot of all of it. So talk about Ovechkin, right? So just linking him to the history, to what he's doing, who he's chasing, and what that means. We've done very little of that, and it's very difficult to pull up highlights from Wayne Gretzky. There are a couple big ones out there, but if you want to look in the cracks, that's not easy. So there's that. Statistics in hockey really haven't evolved very much in a very long time. We really dug into this with our tracking system and some of the things that we're all doing now. But you can just go back about 5 years and take goalies. Goals against average and save percentage were the two primary stats in 1917, and they were in 2017. It was the same two. Whoa. And part of it's because it's difficult to capture. The game moves fast. There's tons of variability. It's the only professional team sport where personnel changes are made live in play. So capturing all of that to create a data set was difficult. Anyway, so stats and analytics to use to help explain why the game is the way it is in the United States is a big area for us to potentially focus on. And then the last one is you mentioned the stars. And that's if you played hockey or okay, so people who play hockey know there's this cultural thing where our players, if there's a pro and a con, they do not want to put themselves out there. They really don't want to be stars. And I could bore everyone with a story about Sidney Crosby in his rookie year was this phenom. He's supposed to be on the Jay Leno show. There's a whole thing about it. We got a call from his head of PR, and they said he's not going on the show today. And we're like, what happened? Is he sick? Did he get hurt? And they're like, we don't know. They put Sidney on the phone. He just said, I played terrible the last 4 games. We've lost 3 in a row. I'm not going out there. Wow. That's hockey players. But it hurts us because we want people to know everything about him, right? We want them to get out there on social media, and they're not willing to do that. So there is kind of more of a produced, NHL produced kind of player angle on all this, where we want to capture footage and use it to explain why Alex Ovechkin is amazing, or Connor McDavid, or whatever. Yeah.
Faber dances, right circle, now wraparound score!
If you have use cases where you feel like this type of model and pipeline will help you, then reach directly out to Adam, and he can point in the right direction.
Yeah. We also have a booth that's in the under the giant NVIDIA sign. You can't miss it when you go in there. So there's some general purpose use cases that we're using VSS in that you can go and test out. So thank you.